In this lesson, we shall focus on mathematics, MATH141 calculus, a UKZN module. We shall look at techniques of integration, shall solve a wide range of problems as shown on the board and move forward. Right, mathematics 1B, MATH141, tutorial 3, part 2, from the 12th to the 16th of August. And we're looking at the integrating trigonometric functions, obtain the integrals of the following functions. And we see how best we can do all these here. And we're getting started. Now let's look at the first question first. Right, so given, for example, the part A here, obtain the integrals. How do we do this? We are able to do this with so much ease as follows. First things first, if you're given the integral of the sine cubed of 7 theta d theta, we simply let u be 7 theta. Right, in an attempt to sort of simplify the arising angle. Right, and with this, we're able to know that du is 7 d theta, like so. Meaning at this point, we have that we can write 7 cubed, 7 theta is u, d theta is du out of 7. D theta is du out of 7. And this is equal to 1 over 7, the integral of the trigonometric sine cubed of u du. Exactly like so. Moving forward, what do? We can do this. Okay, so we actually therefore have already the 1 out of 7, the integral of the sine cubed, right, of the sine cubed u du. In other words, we have the fact that the integral of the sine cubed of 7 theta d theta is 1 over 7 the integral of the sine cubed of u du. Precisely like so. Now, what do we do with this? We always, if the power is odd, the power is an odd number. 3 is an odd number. So what we do, and this is the technique, right? What we do is we write sine squared u, and then we break it down to the sine u du, precisely like so. And then we are able to move forward. We're able to move forward. And with this, we are able to realize that, you know what? We have the solution. If only we can be in a position to say that this is 1 out of 7, the integral of. We know from metric that sine squared u, we know from metric that sine squared u from high school plus cosine squared u, this is always 1. Simultaneously, this implies that whenever we have the sine squared of u, it is 1 minus cosine squared. Precisely like so. So that whenever we have the sine squared of u, we can actually be in a position to write it as 1 minus cosine squared. So that here we have exactly 1 minus cosine squared. 1 minus cosine squared u, the sine of u. The sine of u. du. Okay. Now, what is this? You multiply through by the sine, giving us exactly 1 over 7. The integral 1 over 7, the integral of sine u du minus 1 over 7, the integral of cosine squared u sine u du, like so. Now, what are we able to achieve out of this? Right, we are able to look and tell that we are reaching exactly the final result of this particular problem here as follows. We take a look. This actually then implies that we have here the integral of this, but this is exactly equal to the integral of the cosine u is negative 1/7 the cosine of u. If you let u to be cosine, the derivative of the cosine is negative sine. Let's show a bit more steps here to avoid problems. Let's show a little bit more steps here to avoid problems. Right, we want to avoid issues, meaning the integral of the sine cubed of 7 theta. This integral is 1/7. Yeah, the integral of the sine u du minus 1/7. And then what do we have? We have the integral of the cosine squared. U, the sine of u, du. Okay. Right, so now this one you can easily integrate, but the problem is here. So we shall let v, right, we shall actually let v be equal to cosine u. Let v be cosine u, so that dv is minus sine u du. Simultaneously, du becomes dv divided by the trigonometric sine of u. So we're dividing by minus sine u, so that at this point, we know that the integral of the sine is negative cosine, which is negative 1/7, the integral of the following. Or maybe before we do that, let's just do the integration at the same time. So we can just, in the meantime, maintain and keep 1/7 the integral of sine u du minus 1/7 the integral of, now the cosine squared is the same as v squared. Right, and then you can put here sine u, but what is the du? The du is dv divided by negative sine u. Precisely, like so. The sign cancels out. It does cancel out. Yeah. Giving us negative, or let's keep 1/7 still, the integral of sine u du. Now, the negative and negative gives us plus 1/7, the integral of v squared dv. Let's find the integral now. We're ready to integrate this one. We can also integrate this one. Right, the integration would therefore become negative 1/7 cosine u. Now exactly plus 1/7. What is the integral of v squared? It's 1/3 v cubed plus c. And this is actually minus 1/7 cosine u. What is u? We remember that u was equal to 7 theta. So you put 7 theta. And then the 7 times 3, it's 1/21 in the denominator. The v is the cosine. Is the cosine of u, but u is 7 theta plus c. And this is the answer. This is exactly the solution. Take a look and reason with us. this is exactly the solution to this problem. Take a look and think. Okay, now let's check. Minus 1 over 7 cosine theta, minus 1 over 7 cosine 7 theta plus 1 over 21 the cosine cubed plus c. Let's check. Yeah, it's exactly this one here. It's exactly the solution that was given. It's exactly that one there. Right, and we proceed without wasting much time. Right. So move forward. Right. So now we're looking at part B. Now, if you look at part B, we have this integral here. Now, having this integral where you have an odd power, 3. You have 3, which is odd, but also you have an even power. Even power is 4. So now you need to look at this and reason it out. The question becomes, what exactly needs to be done here to be in a position to actually be in a position to get the answer? So you need to actually have a strategy, but a strategy that will allow us to get the answer with so much ease. With so much ease. Now, what exactly do we do exactly at this point? And we take a look. We're gonna first deal with the fact that we have the integral from 0 to pi of 3 cubed 9x. 9x. And then we have the cosine of to the 4th power of 9x dx. We let u to be the same as 9x. du is exactly 9 dx. Like so. Now, the best is sometimes you just leave out the limits of integration. Just leave out the limits of integration, perform the integration, and then you can put in the limits of integration later on. So that becomes sort of the strategy, because you need to just devote much of your time to really making sure that first we get the correct integration, and then we can take the limits of integration there. So now at this point, we then are able to achieve the sine cubed. What is 9x? It's u. So you put u. Cosine to the 4th power u. Dx is du out of 9. 1 out of 9. So cosine to the 4th. Like so. Right. So now this is what we have. So it therefore means that we need to take note of the fact that the integral of the sine cubed of 9x cosine to the 4th power of 9x dx. This integral is exactly the sine cubed u, and we can see that there is a 1 out of 9 here. And then we also have the cosine to the 4th power of u, and we have du. That way, it's 1 over 9 multiplied by that. Now, looking at this, we are actually in a position to do further algebraic manipulations and obviously using our techniques of integration here. Now, when the powers are such that there is an odd power, the 3 is odd, and this 4 is even, we then can be in a position to see what exactly to sort of achieve. So this is the strategy. The strategy is to break down the odd power. So we're going to have 1/9 the integral of. Look at the odd power, forget the even, and break it down. And if we do exactly the breaking down, we're going to break it to the sine squared of u. The sine of u, cosine to the 4th power of u, du. We're good. We're so good. And then now the ball game begins. The ball game starts. So we look at the odd power, only the odd. Forget about the even. Always, if it's sine or cosine, same thing. Just look at the odd. Like here, we looked at the odd and we broke it down. So here, you look at the odd and you break it down to a square, and the other one obviously there. Okay, and so you continue as follows. Now, what is the next thing that we can achieve here? The next thing to achieve is to then say what you have. If you have the integral of the 1/9, the integral, what is sine squared? 1 minus cosine squared u. Sine u. Cosine to the 4th power du. So now you multiply things out, getting 1/9, the integral of the sine of u, cosine to the 4th power of u du. 1/9, the integral of sine u, cosine to the 6th power of u du. Because cosine squared times cosine to the 4th power is cosine to the 6th power, and then the sine is there. And then the sine is there. At this point, you let v be equal to, now you let it to be the highest power. So which means that you let that be actually the cosine of u. This means that dv is minus sine u du. But what is du? Du is dv divided by negative the sine of u. Meaning that at this point, we have the following. Right, at this point, we have exactly 1/9. We have precisely 1/9, the integral of the sine of u. What is the cosine? It's v to the 4th power. What is du? It's dv divided by the negative sine u. Minus 1/9, the integral of the sine u, v to the 6th power du is dv divided by the negative sine u. And then now this cancels out, and we have minus 1/9, the integral of v to the 4th power du minus plus, okay, negative it's plus 1/9, the integral of v to the 6th power dv. Right. With this, we then have the integral sine cube 9x cosine the 4th power 9x dx. The integral, what is this? Check. Minus 1/9. Minus 1/9, the integral of v to the 4th power. Plus 1/9 The integral of v to the 6th power dv. V to the 5th power, 1 over 9, 1 out of 7. Because it's v to the 6th power, the integral is 1 out of 7, v to the 7th power, plus c. Minus 1 out of 9. 1 out of 9 by 5 is exactly a 45. What is v? We know very well that v is cosine u. So in the place of v, you can put cosine to the 5th power of u. 1 out of 9 by 7. What is 9 by 7? Right, 9 by 7 equals what? 63. So you have 63 here. The v, what is the v? It's cosine u. The v is actually exactly cosine to the 7th power of u plus c. 1 out of 45. What is cosine u? It's cosine of what is u? We said let u be 9x, so that wherever there is u, we put exactly 9x plus 1 out of 63. And then we have the cosine to the 7th power of 9x plus what? Plus c. Check this out. Check this out. And this becomes precisely the result. Let's check this. The minus 1 out of 45 cosine the 5th power of 9x plus 1 out of 63 cosine the 7th power of 9x plus the arbitrary constant of integration c. Oh, we are not done yet because we actually were given these limits of integration. These kinds of integrals are definite. Definite integrals. So this one is a definite integral. These are definite. Yeah, this one is a definite integral. This particular one in B, but yeah, it's different from exactly that one there. So we continue as follows. So we already have got. So now we consider the integral from 0 to pi over 3, which is actually the same as the sine cubed of 9x, the cosine to the 4th power of 9x. We have already seen it's minus 145. Cosine to the 5th power of 9x plus 163 cosine to the 7th power of 9x. That c, we added it because we left the limits out, but now that we are considering the limits, we can forget about the c and then take everything from 0 to pi over 3 radians, just like so. Meaning that at this point, you plug in the limits and you have minus 1 out of 45. The cosine of pi over 3 to the 5th power. 1 over 63 cosine to the 7th of pi over 3. Okay, with the 9. So that's going to be exactly 9 pi over 3 here. On this one, it's exactly 9 pi out of 3. Minus 1 of 45. The cosine of the 5th power of 0 plus 1 of 63. The cosine of the 7th power of 0. Which is minus 1 of 45. Cosine to the 5th power of 3 pi. 1 out of 63. Cosine the 7th power of 3 pi. Minus. This is what we are able to achieve. So this is minus 1 of 45 plus 1/63, because cosine 0 is exactly a 1. Right, so allowing us to, the cosine 3 pi is, it's a negative 1. So that we have exactly minus 1/45 with minus 1 to the 5th power, giving us just a negative 1 plus 1/63, negative 1 to the 7th power, which is just exactly a negative 1 minus, right, negative 1/45 plus 1/63, like so. We use our calculator to get the results. The calculator, precisely here. Let's launch our calculator and get the result. So we have negative 1/45. Okay. I had lost it there. My sincerest apologies. Right. So you therefore have a negative 1, which you raise to the 5th power, plus 1/63, which is exactly negative 1 to the 7th power, minus 1/45 plus 1/63. 1/63. Like so. All right. Yes, it is a negative. Yeah, it is exactly 1/45. Yeah. It is 1/45. But now the answer becomes 4/315. We're getting 4/315 if we sort of, simplify everything. So we need to check this one, if it is correct or what. The 4/300. Yeah, 4/315 is the correct answer. 4/315 is the correct answer. Let us check this out and see what we have. What have we got? Exactly what have we got? Okay, we have taken the fact that at this point, how did you get -1? Because what is cosine 3 pi? What is cosine 3 pi? Cosine 3 pi is -1. Yes, please.
Yes, I got lost where at the part where we got -1/45. I understand the -1 in the bracket, but the -1/45 cos 5
Okay, let me see.
x.
Oh, you're saying where is the -1/45 coming from?
Yes, the negative part is because I thought it was positive.
Okay. Let me see. Because we started here. Let's recap very quickly. This is where everything started. Okay, let's recap quickly. We started with this particular question, and we're doing the sine cubed of 9x, the cosine to the 4th power of 9x dx. And we said let u be 9x, and wherever there is 9x, we put u. 9x, we put u. But also, we're able to see that dx itself, from this dx is du out of 9. So now dx becomes du out of 9, so that we have 1 out of 9 like this. And then we have the sine cubed of u, the cosine to the 4th power of u. Now, as a consequence, this is what we have. But what did we do? We actually broke the odd power, the sine cubed to sine squared times sine. And then the sine squared, we know very well that sine squared is 1 minus cosine squared from school. And that allowed us to actually get exactly the sine u cosine to the fourth power. But also when you multiply cosine to the fourth power and cosine squared, it gives us cosine to the sixth power with the sine u. And then now we say let u be the cosine u. So whenever u is cosine u, we actually, wherever it is cosine, in particular, we put v. Wherever it's cosine u, we put v, so that we have v to the fourth power. And we put the du, because now du becomes dv over minus sine. Okay, and that allowed the cancellation to give us v to the fourth power. Okay, if it's minus 1 over 9 v to the fourth power, we get this. Okay, now v to the fourth power is 1 over 5. And this is v to the sixth power is 1 over 7. But now we have 9 times 5, which is a 45, cosine to the fifth power. Plus 9 by 7 is 63, cosine that. Okay. All right. Okay, good. So that the rest, we do the substitutions there. We've already got the integral there. Okay, and we're able to get the final step. And indeed, the answer is 4 out of 315, because that is exactly the same answer that your lecturer wrote there. Now we continue to do further integration, but this time around we are doing integration of the following. Now the question becomes, what is the integral of, for instance, if you're dealing with the sine squared of x, and then we have the cosine to the fourth power of x. Right, so we need to reason this out, but what exactly can we do at this point? Right, what exactly we can do at this point is the following. Part C. Part C, we have this. We have the integral of 8 sine squared x cosine to the fourth power of x dx. So what do we do here? What we do here is to realize immediately that cosine squared is the same as 1 minus cosine squared x. Obviously, the reason is that sine squared x plus cosine squared x as usual is always 1, and that means that whenever we have sine squared x, it is 1 minus cosine squared x. So that whenever the sine squared is 1 minus cosine squared x. Cosine to the fourth power of x dx. What exactly now do we achieve here? We're able to get the result as follows. We're able to get the results as follows. Now, then we actually perform just further distribution at this point. We perform further distribution as follows. So this becomes exactly 8 the integral of cosine to the fourth power of x dx. 8 the integral of cosine to the sixth power of x dx. Right, so okay, this is what we got, but now we need to do this integration part by part. It's not really integration by parts that we're going to do, but we're going to proceed to do the integrals, doing term by term integration. So we actually therefore continue to tackle the following. So now, if we have the cosine to the 4th power, what exactly can we do with this here? Right, so to do this one, we need to break it down. We need to break it down. So how do we break these down? For example, because you already have the cosine to the 4th power, right? So whenever you already have the cosine to the 4th power, how do you actually maneuver that? And we reason that together. So we need to use specific techniques to be in a position to find the integral of the cosine to the 4th power in a step-by-step fashion. So we do precisely that. So we have the integral of 8, the sine squared of x, cosine to the 4th power of x dx. And this becomes exactly 8. The integral of cosine cubed. The integral of cosine cubed of x. And then this is also cosine x dx. Minus the integral, minus 8. The integral. Right, minus 8, the integral of cosine to the 5th power. Right, so if you have cosine to the 5th power, right, cosine to the 5th power of x, and then we have cosine x dx, exactly like this. So now the question is, what are we able to achieve out of this? Well, we need to do part by part. We need to focus on this integral. So focusing on the integral, focusing on 8. So leave everything out. And do 8, the integral of cosine cubed of x, cosine x dx. What do we do? Now, this one here, you need to perform integration by parts. And integration by parts means what? We need to choose the things you can easily integrate and the things you can easily differentiate at this point. Because whenever you get this part here, we shall therefore be in a position to choose what to integrate. So you're going to let. Okay, by integration by parts, we remember that we actually mean that we're going to use the integral of u dv, uv minus the integral of v du. So that you let exactly u be cosine cubed x, and then the v would be the remaining cosine of x dx, meaning the integral of this is going to be u, which is cosine cubed. And then now if divides this one, then you can integrate dv. You integrate the dv, have the integral of cosine x dx, which is exactly v, the sine of x. 8, the integral of. Okay. So now let's put out the 8. Which means that this is going to be u. What is u? It's cosine cubed. V is the sine. So cosine cubed, the sine minus the integral. V du. What is the integral of V du? Because u is this one, which means that du is going to become what? It's going to become 3, the integral of cosine squared x minus the sine of x dx. So that here you're going to have by the chain rule. So that now we have v, and v is the sine, but du is what? Du is 3 cosine squared x negative the sine of x dx. Like so. Which is exactly 8. Right, so you distribute here, and so this one is going to be 8 cosine cubed x sine x. Negative times negative gives us a plus 8, the integral. Okay, but it's 8 times 3. And 8 times 3 gives us exactly a 24. 8 times 3 gives us exactly a 24. And then that is 8 times 3, which is 24. Then you have the sine squared x. And this one becomes exactly cosine squared x dx. Like so. Okay. Now we are in business. We are in business. Now at this point, you are able to see that you actually have the even powers of this. So what exactly do we achieve out of this? We reason together. So now this becomes exactly sine squared. Cosine squared, and you reason that integral out. And to reason this integral out, we need to do the following. Right, this integral, it's easy. If ever it's sine squared, cosine squared, when the powers are even, like this, we can be able to write this one as follows. Right, you can start from the margin. So we have 8 cosine cubed x, the sine of x, 1 out of 24. Which means that we can write this one as what? You can write it as the sine of x cosine of x squared dx, like so. Okay, we just pull out the square to cover everything. And then we remember from metric, from high school, that the sine of 2x, it's 2 sine x cosine x. But now the 2 is missing here. Because the 2 is missing, what we're going to do is we're going to... Yes, please.
Yes, may I ask, how did you get the 1/24?
How did we get the 1 out of 24? Right, so obviously that one must just be exactly simply 24. Well done. It is still just 24, you agree? Right, it is still this 24 here. It is still this 24. Well done to you there. Okay, right, it is still this 24 that has been obtained because it was 8 times 3 which produced the 24 there. Okay, just that I'm already thinking ahead. Okay, right. Now, but there's some incorporation you need to do because we need to put a 2 here And I was already thinking of a reciprocal that needs to be introduced. Right. So now we proceed to then say 8 cosine cubed x sine x, which is exactly 24. The reciprocal to be introduced, there's a 1 over that to be introduced because there's a 2 that is missing inside here. So we're going to introduce 1 out of 4. And we shall introduce a 2 sine x cosine x. So you have dx. Okay, now look. Okay, with the square here. If you square the 2, it becomes a 4. And the 4 and the 4 canceled out. So then we're able to achieve this one. You can write it as it is. The 8 cosine cubed x sine x. The 24 divided by 4 becomes exactly a 6. Then we have the integral of. Now, this one, what is 2 sine x cosine x? This one, what is 2 sine x cosine x? It's exactly the same as the sine of 2x, because sine 2x is 2 sine x cosine x. Then there is, but it is squared, right? It is exactly sine squared of that. Then there is a dx like this. So now we are back. We're going to take this one here. It is actually exactly equal to this one there. So in other words, we can even write here and say this is exactly 8 cosine cubed x sine x plus 6. What is the integral of this? For us to integrate a single even power like this, we remember the same thing about the trigonometric sign, but we go back to high school and remember how we actually have been able to do this in terms of the cosine of 2x. It's 1 minus 2 sine squared x. So if this is true, what is sine squared? It is exactly cosine, but this angle is double. So if this one is 2x, this one is double that, so this one is going to be 4x. This one is going to be exactly 4x by the double angle formula. So that now whenever we have sine squared of 2x is the same as what? From this, we have the following to achieve. We're good. My goodness. Sine squared of 2x, which is cosine 4x minus 1 divided by 2. Just like so. Like so, like so, like so. Meaning that whenever we have sine squared, it is cosine 4x minus 1 out of 2 dx, which is exactly 8 cosine cubed x, the sine of x. Now, the 6 divided by 2 is exactly a 3. The integral of cosine 4x minus 1 dx, just like so. At this point, we already know that 8, the integral of cosine cubed x cosine x dx. Cosine cubed x cosine x dx. 8 cosine cubed sine x. 8 cosine cubed x sine x. plus 3. Cosine for x minus 1. Dx. So what is this? It's 8 cosine cubed x sine x plus 3 cosine 4x dx minus 3 the integral of dx, meaning giving us 8 cosine cubed x sine x. What is the cosine of 4? Okay, sometimes we're going to be quick with this so you don't waste time. The cosine of 4 is always the 1/4 is going to come out. So it's going to become 1 over the coefficient of x. But the integral of the cosine becomes the sine. So it becomes 3 out of 4 the sine of 4x. And then this integral of the dx becomes simply x plus the arbitrary constant of integration c. We have just been in a position to obtain 8, the integral of the cosine to the 4th power of x dx. Just like so. We can use integration by parts there. We can use exactly integration by parts like that. And obviously there are a couple of ways to do it, but integration by parts becomes something we can do. But yeah, there are just too many ways to do these particular questions. Let's move on to the next one. The next one is this one. We also have cosine to the 6th power of x dx, which we broke down to 8 cosine to the 5th power, cosine 5x. So we need to do that one, the cosine to the 6th power. Okay. So we proceed with that one as follows. Right, so we have the integral. So we can take 8, the integral of cosine to the 6th power of x dx. 8, the integral of cosine to the 5th power of x dx. Okay, y'all. To the 5th power like this, dx. So now, this is what we're able to achieve. This is what we're able to achieve. Let us reason this out together. So now the question is, how would you do the integral of cosine to the 6th power? So now we must reason this out and then say, if it is cosine to the 6th power, what exactly do we do? What exactly are we able to achieve out of this? Right, so now, there are a couple of things, obviously, you need to reason out. And one of the techniques you can actually be able to use is using, for example, sum reduction formulae. So you need to reason this out. You need to reason this out. So now we ponder exactly this integral. You need to be very strategic to avoid wasting time, because we do not want something that is not going to work, but want something that is going to work. So what technique is actually going to help us to do this with so much ease? Okay, each of these is quite a bit heavy in the calculations. Right. So we actually can be in a position to do as we simply please. Right, and also there are so many results that can be used. Okay, we're pondering this so that we can use a very, very strategic approach in doing this. Right, so let us reason this simply together. Because now this one here, okay, yeah, the easiest way would be this one. Right, so now if we're able to break it down, for instance, see, there are too many ways. If we can break it down to the following, right, so you can break it down, for instance, to precisely the cosine squared, and then you cube it, dx, you cube it, dx, which is 8 the integral of. What is exactly the integral of the cosine squared? Right, so we're able to see that the integral of the cosine squared becomes what? Right, so the integral of the cosine squared can be written in terms of our double angle to sort of eliminate the square, meaning that cosine 2x is exactly the same as what? It's exactly the same as 2 cosine squared x minus 1. Right, so that whenever we have cosine squared, you can write it as cosine 2x plus 1, and you divide by 2. And this becomes cosine squared. Right, so yeah, I'm going to use it. Cosine 2x plus 1 out of 2, and then you cube it, dx. Right, so we get exactly that. And so this one here is going to be exactly the same as, now you have this 8 here, but there's 2 cubed, which is 8. Is going to give us exactly 1 out of 8 out of 8, the integral. So when you raise this one to the power cube, it's the same as the following. So it becomes exactly the cosine cubed of double x, 3 cosine squared 2x plus 3 cosine of 2x plus 1 dx. Right, so now we can be able to do most of these integrals. Like this one, it's easy. This one you can do, this one you can do. Now even this one we can do, because it is like cosine squared, so it uses the same thing. So whenever there's cosine squared 2x, this angle is double. So this one becomes double. So the 8 out of 8 cancels out, giving the integral of. So we're going to deal with this one. But now we need to deal with also this one. What is the cosine cubed? So the cosine cubed is very, very easy for us. Right, so yeah, that becomes a strategy you can use all the time. You know, so this is a strategy you can use even in multiple other instances that you will have. Okay, right, so this one you can write as cosine squared of 2x. Then you also have the integral of 2x dx. This one is plus 3. The integral of, what is exactly the cosine squared? Is cosine 4x plus 1 out of 2. Cosine 2x is cosine 4x plus 1 out of 2 dx. Plus 3, the integral of cosine 2x dx plus the integral of dx. Okay, so this is equal to, right, so now we come to this. So this one of cosine squared 2x, cosine squared 2x, if it's 2x, this one becomes 4, but the 2 in the denominator remains the same. Now let's look at this one. This one, when you let u to be cosine. The derivative of this becomes a sine. So we must use the sine somewhere. So cosine squared, 2x will be 1 minus sine squared, 2x. Okay, with the cosine 2x. With the cosine 2x dx. Now this one becomes exactly 3 over 2, the integral of cosine 4x plus 1 dx plus 3, the integral of the cosine 2x dx plus the integral of dx. Okay, now let us check what we have here. So this one is the integral of 1 minus sine squared, 1 minus sine squared, 2x, cosine 2x. The integral of this one plus the 3 cosine 2x dx plus the integral of dx. Right, so what is this? What is this? This you can distribute, getting exactly the integral of cosine 2x dx, and then minus the integral of sine squared of 2x, cosine 2x dx, plus 3 over 2, the integral of cosine 4x plus 1 dx, plus 3, the integral of cosine 2x dx, plus the integral of dx. Right, we are in business now. Let us perform the rest of the integration. So the integral of the cosine, the 2 becomes like 1/2. The integral of cosine is sine 2x. Here, if you let u to be the sine, the derivative is cosine. But it's not only that the derivative is going to be cosine, but the derivative is going to be, if you let u to be sine 2x, like this, du is going to become 2 cosine 2x dx. So which means that dx is going to become du over 2 cosine 2x. Right. Yeah, so this cosine is going to cancel, giving us 1/2. So there's going to be a 1/2 that's going to come out of it. Because the u was the sine, then it becomes exactly the sine cubed 2x. Okay, this 2 is going to be the one that's there. So you don't need to show a lot of steps there. And then now there is a 3 over 2. What is the integral of cosine 4x? The integral of cosine 4x becomes 1/4. The sine of 4x. And then the integral of the 1 with respect to x is just x. Plus 3, the integral of the cosine 2x becomes 1/2 the sine of 2x plus x plus c. 1/2. So which is minus 1/2. So which is exactly the sine of 4x, 3 over 2x. 3 over 2, the sine of 2x plus x plus c. Right. And what exactly is all this thing here? This one is actually the integral of the, this is actually the integral of cosine to the 6th power. Is the integral of cosine to the 6th power of x dx. Right, the integral of cosine to the 6th power. Okay, so we remember, and yeah, we have put 8 here. So when we put the 8 in front, the 8 disappeared by cancellation. So we are back to the question. We are back to the question. So that when you have this integral here of 8 so whenever we have the integral of 8 sine squared of x cosine to the 4th power of x dx, what is this integral here? This integral, we've seen that it is actually exactly 8, the integral of cosine to the 4th power. Right, it is exactly to the 4th power of x dx minus 8 to the 6th power. To the 4th power of x minus, with respect to x, minus 8 minus 8, the integral of cosine to the 6th power of x dx. Cosine to the 4th power. Okay, so y'all, what is this? Dx. Okay. Dx. Okay, so that's what we have. Now, what is this? So we perform the rest of the substitutions because we have already got the rest of these integrals. Like we did the one, the 8. What was the 8? The 8 cosine to the 4th power is actually exactly this one here. Let's check it out. So, okay, you take note of this, and these are the sort of things you can sort of apply to learn. Okay, the strategy to learn anything is to start from the tutorials, and then you can go to the textbook, because the textbook is so big. And so by problem starting with the textbook, we're going to take a lot. We're going to take a lot of time before we finish the whole thing. So this one here, becomes exactly what we have. Becomes exactly what we have. The cosine to the 4th power, we did 8 of this. And when it did 8 of that, what did we achieve? We got exactly 8 cosine cubed x sine x plus 3 out of 4 the sine of 4x minus 3x. Now we also have done the cosine, the 8 with the cosine, this one. Cosine to the 6th power. Cosine to the 6th power. which became exactly 1/2 the sine of 2x, but you distribute with the minus. So this one is going to be exactly plus 1/2 the sine cubed of 2x minus 3/8 the sine of 4x minus okay. Okay, that's fine. That's fine. Okay, yeah, we're gonna go back to the previous tutorial. So that we have exactly this one, sine 4x minus, okay, that's fine. 3/2 x minus 3/2 the sine of double x the sine of double x minus x plus c. Right, now let's see if we have some like terms. Yes, we have some like terms. So that now, with the like terms that we've got, okay, we're going to go back to the previous tutorial. So that we have 8 sine squared x cosine the 4th power of x dx is equal to, let's see now, cosine cubed sine x is the only one. So with 8 cosine cubed x sine x. Now the sine for x is this one and this one. So if you have 3/4 minus 3/8, 8. Divide 8 by 4, you get a 2, you're getting a 6 minus 3. Divide 8 by 4, getting a 2, and you have exactly that, which is actually 3/8. So with these two, it's exactly 3/8 for x. So we're done with this one, we're done with this one. Right, so we also have to deal with this one, minus 3x. Yeah, okay, let's deal with the sine 2x. But we also have the 1/2 sine cubed 2x, which is the only one. We're done with this one. And then the sine 2x has produced the minus 1/2, and then it's produced the minus 3/2. Okay, so a minus 1/2 minus 3/2 would give us minus 4/2, which is a minus 2. Minus 2 sine 2x. So we continue. Right, so that in the end we have minus 3x minus 3/2x minus x minus 6x minus 3x minus 2x. Which is exactly minus 8 minus 11x out of 2. Minus 11x out of 2. Right, so you have exactly minus 11x out of 2. We shall get back to that, just checking. Plus c. Okay, so this would be sort of the answer to this particular problem. I understand that obviously you'll go back to the other tutorial, but we're taking a look at this one and making sure that we sort of are able to get the required answer is the answer to most certainly the part C. Right, most certainly the part C. But yeah, there are different ways, obviously, of being in a position to get exactly this result here. So take a look and try to most certainly make sense of this. But once again, you see, the thing is, with integration, there are just so many techniques that can actually be used to the extent that the answers might look different, yet very, very equivalent. Okay, so now we'll continue to the other tutorial. Let's continue with the other tutorial. Right, continue with the other tutorial. And as I said already, you can always be in a position to get different answers to questions. Right, so the other tutorial is exactly this one here that we're looking at. And we've already done some parts of the tutorial, but we actually did number 4. Now, for instance, if you look at the tutorial B, like question B, because we have already looked at this one by using integration by parts. So using integration by parts, which means it is u dv, which is uv minus the integral of v du. Okay, yeah. You let u. Right, let u be, for instance, 2x squared, so that dv is the same as cosine x dx. So du becomes exactly 4x dx. If you integrate both sides, you get a v, which is exactly the integral of the cosine, which is the sine of x dx. So that whenever you have the integral of 2 cosine squared cosine x dx, it is u, which is 2x squared, and the v is that 2x squared sine x minus the integral of v Okay, good. I'm glad that we have actually done this one. So let us move on to the next one. In an attempt to not to be repetitive. In an attempt to not to be repetitive, let us move on to the next one. Right, so we're gonna do, for example, the next one, B. So we're gonna do B, and to do B, we are focusing on the integral of e to the minus x sine x dx. And so this integral here, we need to choose what it becomes u and what becomes du. In principle, it doesn't really quite appear to matter here. So you can let u be, for example, e to the minus x, and v be sine x dx. If you take the integral here, you get v to minus cosine x. Dx. The integral of u dv equals uv minus the integral of v du, which is u v. Right, so it is uv minus the integral of v, which is minus cosine x, du minus e to the that dx. So that you have this one. Cosine x plus so plus, which is negative e to the minus x cosine x dx. Okay, now we actually have this, and we need to continue and do the same thing. So we're going to have the integral e to the minus x, the original one, the sine x dx, which is the original one, but we have integrated by parts using the u dv formula, and we got minus e to the minus x cosine x minus the integral of e to the power minus x cosine x dx. Meaning at this point, we then are able to achieve something. We're able to achieve exactly something. What exactly is the something? We need to deal with this one. So we actually still use integration by parts, but you remember the choices sort of we had, so that so u was e and the dv was the remaining part. So we're going to do the same and let u be e, dv be cosine x, du, which is this, dx sine x. The integral of cosine is sine x. So that now, when you get to this point, this becomes minus e to the minus x cosine x minus. Okay, using this and integration by parts, that says u dv is uv minus the integral of v du. Right, so it's going to be u, which is e to the cosine, and the v is going to be sine. So now there's e to the minus x, and therefore this is v, which is the sine, because v du, v is the sine. So v is the sine, and then du is minus e to the minus x dx. Just like so. Okay, so this is minus e to the minus that cosine x minus e to the minus x sine x. And then now we have negative, negative plus by negative, negative. The integral of e to the minus x, the sine of x, dx. So now we are back. We have this one together with this one. And we are having the following. For this one, it is the integral of e to the minus x sine x dx, which equals minus e to the e to the minus x cosine x minus e to the minus x cosine x minus e to the minus x sine x minus e to the minus x sine x dx. So this one and this one, you bring them. This one is negative. If you bring it here, it's going to be positive, giving us 2 this sine x dx cosine x plus C1, arbitrary constant of integration. Divide both left and right by 2, getting exactly the integral of e to the minus x sine x dx. Divide by 2, e to the minus x cosine x, e to the minus x sine x, plus c. Right, so let's check. So now if you check, this is the answer they wrote. So obviously you can pull out a common factor. The common factor is minus 1/2 e to the minus x cosine x plus sine x plus c. All right. So that's the answer. That's the answer. And that becomes the answer. So we have got this one because the answer obviously is also the same. But it remains to do C. C. Let's do C. In C now, we have the integral of ln x dx. The integral of that, you let u be ln x. Right, so if u is ln x, because we need to integrate this one, then it means that you can be able to find du. Du becomes exactly 1/x dx. So that e to the u is x. So that we have the integral of what is dx? Dx, according to this, it's x du. Wherever there is dx, x du. What is x? It's e to the u cosine u du. So this is what we get. This is what we achieve. So now, e to the u cosine u du. So now we need to integrate this one, and the practice is the same. We let u be cosine, for example, can let u to be e, dv be sine.
Sorry,
Like that? Yes?
Can you
Cosine
please
u.
go back? I got lost where you got the e to the power of u. Sorry.
Okay. Right. So because we are looking at the fact that u is ln x, so we let u to be ln x. So when u is ln x, what is the ln? Is the log of x base e. So ln x is the log of x base e. Right. So if ln x is the log of x base e, then you can write e to the u is x by exponentiation. Right. So that's what we got. And then now here, wherever there is, because now cosine u, ln x is u. But what is the x? It's x du. What is x? Now we need to solve for x from this. If u is ln x, then we can see that x is e to the power u. So that wherever there is in this place of x, you put e to the power u, and this becomes e to the power u cosine u du. Okay, so that we have this. So we have this to integrate now, and we're using integration by parts, which would have not been possible quite because this one it's a challenge. I mean, you can't integrate by parts straight away, because even if you make this whole thing du, if you make this u, the derivative of this is very, very tricky, I would imagine. So this becomes sort of the way out of it. Okay, but yeah, there are always many ways to integrate, but we know how to integrate the e to the u, because that is why normally we do it first, and then we can do the other transformed versions. Okay, so u, right, so now we come here, we let, okay, the variables themselves are very, very interesting. So I feel that because now we have u already, can we use a different variable here? In the place of the u, we use something else, so that we can have the u for integration by parts. So that we can have the u for integration by parts. Can have the u for integration by parts. So we're going to use the, let p, for example, so that the derivative of this one is going to be dp. So dp dx is that. P is in x, p is this, which is e to the p is x. Okay, so this one is dp. So this one is p dp. Okay, I'm trying to resist because we need to continue with the integration by parts. So now, if this one is, what is x? X is e to the p, so that you have cosine p, but x is e to the p dp. Okay, I'm trying to make sure I use different variables. So now we come here, we've transformed that integral to e to the p dp, e to the p cosine p dp, right? Cosine p dp. We come to this, we let u be e to the p dv, which is cosine p dp. So therefore, this is the integral of this. E to the p is actually a u. U is e to the p. The cosine of p is equal to what? Anyhow, what I'm saying here, it is integration by parts we're doing. So let's first find the u equals e to the p dp. And then this one here, you integrate both sides, and you get v is actually the sine of p. Yeah. Okay, integration by parts. U dv is uv minus the integral of v du. U is e to the p, v is that. So it is e to the p sin p minus the integral of v. V, which is sin p. V du is actually e to the p. You can write it as e to the p. Let's write the, normally we write the e first. So it is the integral of e to the p, and we can see the v, e to the p, and the v is the sine of p. dp. We do it again. We have e to the p cosine p. Okay, cosine p dp e to the p sine p minus, is the same thing, this thing. So now for the integration by parts, we can just move very fast. Once we do it once, then we do it very fast. And then say it's going to be u. It's going to be uv. So the u still remains e to the p. The v is exactly this one. Right. So the v is when you integrate these, when you integrate sine, you get negative cosine. Integrate sine, you get negative cosine. Minus the integral of v du. V. If you integrate sine, you get negative cosine. That is our v. And the u becomes exactly that. So it's minus e to the p. When you integrate the sine, you get negative cosine. dp. E to the p sine p plus e to the p cosine p. Okay, this is plus, and then this is plus, and then this is negative. Cosine p dp. Right, so we're in business. We have the integral of e to the p cosine p dp, and this is e to the p sine p. E to the p sine p plus e to the p cosine p. E to the p cosine p minus the integral of e to the p cosine p. Minus the integral of e to the p cosine p dp, and then we take this e to the p, and then with this one it becomes 2 the integral of e to the p cosine of this one, e to the p sine p, e to the p cosine p, plus maybe a c1. Divide through by 2, and this gives us exactly e to the p cosine p dp equals 1/2 e to the p sine p e to the p cosine p plus c. But you need to remember, what is our p? In the beginning, we said, let p be this thing here, be the ln of x. We said, let p be the ln of x. In other words, wherever there is p, we can put the ln. Right, so that if wherever there is p, we're able to put precisely the ln, then we have exactly the following. So we have the integral of e to there. What is p? It is actually ln x cosine of exactly the following. Let me just check what we got here. Let me check what we got here. Check what we got here, what we got here, what we got here. Okay, that's fine. Shall get that. So, okay, wherever there is P, we just put ln x. So this is cosine ln x. Ln x dx, which is exactly cosine x, cosine ln x, excuse. Dx. Okay, what is dp? What exactly is dp? Okay, remember that when you said let p be that. So our dp is 1 over x dx. So our dp is 1 over x dx. 1/2 e to the power. The p is ln x, the sine of ln x. 1/2 e to the ln x, cosine of ln x plus c. Right, in the end, what we're able to get is the e to the ln x. What is e to the ln x? E to the ln x is the same as what? It's the same as x, which cancels with this x, giving us cosine ln x dx is equal to. Now we have this. How does it compare to this part here? Okay, so the e to the ln x, e to the ln x is just x. So this is half x, the sine of ln x. The e to the ln x is just x, giving us half x, the cosine of ln x plus c. So we have half the sine. Right, so you can pull out, you can factor out the half x here, getting exactly 1/2 x. And if you pull out the 1/2 x, you are left with the cosine of ln x plus, pull out the 1/2 x, you're left with the cosine of ln x, and then you're left with the sine of ln x plus c, like that, which is 1/2 the cosine of ln x, the sine of ln x plus c. So that becomes the answer to the part C of this question. So we review the solution, we recap on the solution, and we realize is that what we started with, the cosine of ln x, and we let p be ln x, and dp became 1 over x dx. And then also when the p is ln x, we had to make x the subject because we wanted to transform this into the variable p. So now, which means that ln x is p. Okay, and then now we have dx. Dx is x dp dx. So now in the place of dx, we have x dp. Right. What is x? X. If p is ln x, then you can make x the subject because p ln x, the same as p equals log x base e. The ln is log x base e, and therefore this becomes e to the power p is x. So in the place of x, you put e to the power p. So this integral here has been transformed into the standard form that is actually in the at part B, which is e to the p cosine p dp. So which means that we have e to the p cosine p dp is the integral we need to do, but you already know that with that one, you can just let u be that. I would imagine that generally it doesn't really matter the choice here of the u dv. So you spoil for choice anyhow. Meaning that at this point, if you let u to be e to the p, then our dv becomes cosine p dp, which means that now we find du, which is e to the p dp, and the integral of the cosine p is the sine p, which means the integral of these is actually exactly uv. U is e to the p, the v is sine p, minus the integral of v du. What is our v? Right, our v is the sine p, and the du is e to the p. So we have e to the p sine p dp. Now here you bring down e to the p sine p minus the integral. So the e to the p sine p, still you need to use integration by parts again. So we use it twice in the problems like the e to the sine or the cosine of that. Right, so that in this case now you're gonna let u be integration by parts, so you let u to be e to the p, and the dv becomes the sine. Now, if the dv becomes the sine, to get the v, the integral of the sine becomes minus cosine, and this is u, which is e to the p, minus the integral of v du. The v is the integral of the sine, which is minus cosine, and this is what you get. So this is the case. Right, so that you have the negative and negative, which is therefore a plus. So that now you get exactly this. Now then, the e to the p cosine p, adds up and gives us 2. And we have e to the p sine p plus e to the p cosine p plus that. And then you have the 2 here, you divide both sides by it. Divide by the 2, it becomes 1/2 e to the p sine p, but again 1/2 e to the p cosine p. And then, yeah, wherever there is p, you put ln x, so that you have ln x here, and then you have ln x there. So that now, in this case, therefore, you get this. Okay, because in the place of the p, you put ln x, because p was ln x. And also in the place of the angle of the p, you put ln x. And then now dp out of this, dp becomes 1 over x dx, 1 over x dx. So that now this e to the ln x becomes exactly x, and the x cancels, giving us the cosine of ln x dx, which is exactly 1/2 the x, the sine of ln x, plus 1/2 e to ln x, and that. And therefore now the half x, a common factor, leaving us with cosine ln x plus the sine of ln x, which is exactly the result you're getting. Right, so we have this. And let us proceed now and try more problems. Let's proceed now and try even more problems. Right, so let us try problem. Next one. Problem D. This one. Right. And these things are just pretty much the same. Okay. So now this one, you need to let u be the ln. So if in that case you let u be equal to the ln, du becomes 1 over x dx. The integral of the square root of e x squared dx. So in the place of the u, you put ln x. In the place of ln x, you put u. And then what is dx? Dx is x du. In the place of dx, it is x du. So if you integrate, What is x? X therefore integrates from the square root of e to e. U is ln x. So you have the ln of e, which is 1. The ln of this is 1/2. Right, so it's exactly 1/2 to 1. X cancels, giving us exactly 1/2 to 1. And then you have e to the power x du. What is x? Now from this, we're able to see that x becomes e to the u. Right, so this is exactly integral of 1/2 to 1. And the x becomes exactly e to the u du. 1/2 to 1, e to the minus u du. Okay, so we have exactly this one, meaning that whenever we have the integral of this, the square root of e to e, this one x squared dx, it is the integral of the following: 1/2 to 1, and it is 1/2 to 1, e to the minus u du, e to the minus u du. What is this? This one requires just integration by parts, but you need to obviously just to be careful of the choice you make. The u, sometimes you get into trouble if you start with the u and then you use integration by parts, because integration by parts deals with the u as well. And now I don't want us to change the integration by parts formula to other variables, so we're going to use p again, because we need to use the integration by parts, but the integration by parts has in it, you know, u, and we want the u to be kept for the integration by parts, so let's use p. So now we're going to come here and use p here, dp be that, so that this implies that x is equal to, so this one is e to the p, and this one is p like this, and this is dx. Dx is x dp. Right, so let's continue. And then we have p here. And then this one is, what is dx? Dx is x dp, but the p cancels. You know, there's x squared and then there's x, so it gives us only x there, and then there's dp. And then we get to this, there's p. And then in the denominator, what is x? X is e to the p. X is e to the p dp. So this one is e to the minus p dp. So which is exactly e to the minus p dp, like that. So whenever we have this, we have this, but now we need to use an integration by parts. That is why I went on to use the thing again. So to use the p. And so now we need to let u. U must just be p. Okay, because we want the derivative of, want the p to disappear. The only way for the p to disappear is when we make it u, so that we can differentiate it, and the derivative of the p becomes 1. Simplifying everything. Everything else becomes the v, which is minus e to the p dp. du becomes exactly dp because the derivative is 1. Here you integrate both left and right. The integral dv becomes exactly v. This one is going to just be minus e to the p dp. Like that. So that what you're getting here by integration by parts, the integration by parts formula is that u dv equals uv minus the integral v du. U, p, v is this one. So this is uv, it's minus p e to the minus p dp minus the integral of v minus the integral of v, and v is this one, and then du, which is dp. So it's minus e to the that dp, and yeah, it's v, the integral of du, and then the du is dp. It's dp this way. So what you then gonna get is that this one is gonna be exactly from 1/2 to 1, and then this one, the integral of this one is gonna be 1/2 to 1. You're giving us the negative p. Okay. So okay, this one is, there's no dp here, please. It's just uv. Okay, and the v, please, does not have a dp. Anyone? Okay, the integral of this becomes that, yeah, the v does not have a dp. So where that was coming from. So now we good. What do we have here? You know, just y'all need to bring this closer. Bring this closer to this one. 1/2 to 1. Okay, when you get to this point, then you have this, and then it is exactly 1/2 to 1 minus, yeah. Then this is 1 plus. Negative by negative is plus. But the integral of e to the minus p becomes minus. Becomes minus. Well, because in general, the integral of e to the ax dx is 1 over a e to the ax plus c. So that you have exactly this plus. And then the integral of this one is minus e to the minus p, the integral of 1/2 to 1. So that now you substitute everything, which is exactly that, e to the minus 1 minus 1/2 e to the minus 1/2. And therefore, this is minus the integral of e to the minus 1 minus e to the minus 1/2. So now let us simplify this. Minus 1 over e plus 1/2. Okay, yeah, let us add some like terms here. What exactly are the like terms here? So we already have got, we already have got the integral of this one, the square root of e ln x divided by x squared dx is equal to, okay, it's equal to this one, which is minus exactly that. So we're going to take this one and then we're going to simplify on the other side and then see what answer you're going to achieve. So what you're going to get is the following. Let's check. So what we're able to see here, yes, almost honestly. Yeah, we're almost done, almost done. We're almost done. This is our last, because I know that you need to move. So now we've already got this one. So we carry these things forward and then you write them down, which is -1 in the E and everything. So it's minus e to the -1. There was a 1 times we saw -1/2 e to the -1/2 minus e to the -1 minus e to the -1/2. So that we have this together with this, which is -2e to the -1. And then you have these. You have -1/2 plus, negative by negative, it's plus. So in other words, you have 1 minus 1/2, which is exactly 1/2 e to that. And then what then you are getting here becomes the following. Right, so this you can write as -2 over e plus, okay, let's check. Yeah, there are sign issues here. This and that would be -2, but this one is going to exactly be a plus. Okay, so this one is going to exactly be a plus, which is going to be a +1/2, and this one is exactly a 1, which is exactly 3 out of 2. And this is actually exactly 3 out of 2, the square root of e, which is exactly this here. So we have been able to do the part D. Okay, we're just discussing integration by parts. What you need to do, recap on this one, revise them, and then we shall meet again later on today to continue more. I'll see what to do. We have also the other tasks to do. I'm going to look at the task at the dates for the tests that are coming, but also we don't need to forget the 142 module as well. So yeah, it's something we need to balance up. I'm going to look at the test for both the test dates, and then we actually can strategize. Right, I'm going to make the recording available in the next couple of minutes. Right, it was awesome having this discussion now.